Hi everybody, I am gone today. I'm at the Math League State Meet. I'm going to make a video here so that you can get the information that First Hour got when I was here. I should have your quizzes back to you tomorrow. Today we're going to watch a video about solving equations with exponentials and logs in them. Tomorrow we're going to do more practice with that. Wednesday we're going to review, and then Friday we're going to take the Chapter 7 test. So put that on your calendar and make sure that you know that that's happening because it is. Here goes. The thing that we're going to learn today is about solving equations. And when I mean solve equations, I mean I'm trying to get x by itself. Typically in this equation, I'm going to get k by itself because that's what the variable is. Anyway, a lot of the time when you have a logarithm, you just have to turn it into an exponential equation. If you have an exponential equation, a lot of the time you have to turn it into a logarithm equation to be able to solve it. So in this one, though, this is a little bit weird because I'm starting off kind of not with all the things that I just said. Because in this one, I have log base 10 on both sides. And this is saying that 10 to some power is equal to this, but 10 to some power is also equal to this. And so together I can kind of assume that 4k squared minus 2k must be equal to 80 plus 3k squared. You know when you do something like 3x plus 1 equals 3x minus 7, and you can kind of assume that 3 plus x plus 1 and x minus 7 have to be the same because these two kind of cancel. It's kind of the same idea here where these two things are just the same, and so therefore I can sort of ignore them. So I'm going to just kind of move on with my life and use what I have written in blue. So I have 4k squared minus 2k equals 80 plus 3k squared. It looks like a quadratic, and so I'm back in that mode where I'm like, every time, every unit, we do these problems that get us back to quadratics. And it's like, now I'm affirming again that that was a critical piece of understanding when we learned it in Algebra 2. And so I'm just trying to say, hey, make sure you know how to solve a quadratic. This is a skill that keeps coming back over and over again. I'm getting it to be equal to 0 on the right side because I can solve quadratics when they're equal to 0, but I can't really solve quadratics when they're equal to anything else. So I subtracted 80, I subtracted 3k for squared. I just need to be careful about combining the like terms. So 4k squared and 3k squared are like terms. I'm left with just a k squared. And then I have minus 2k because it's still there, and then minus 80 is equal to 0. So now I need to figure out, okay, what strategy am I going to use? Am I going to factor? Am I going to try to complete the square? I think actually in this one, I think I'm completing the square. The reason for that is because this negative 2, if I divide it by 2 and square it, I get 1. And so it's pretty easy to say, okay, well, if I add 81 to both sides, then I will get 1 on this side. So I'll get k squared minus 2k plus 1 equals 81, which is kind of sweet. Because this thing right here factors as k minus 1 squared. Okay? So then to solve for k, I need to take the plus or minus square roots of both sides. So I get k minus 1 equals plus or minus the square root of 81. Then I need to then I need to just add 1 to both sides. K equals 1 plus or minus root 81. What's the square root of 81 though? It's just 9. So now I've got, okay, k equals 1 plus or minus 9. 1 plus 9 is 10. 1 minus 9 is negative 8. So I've got k equals 10 and k equals negative 8. Just like we had to do on the last time around in the last unit, we do have to go back to the very beginning and plug those values back in up here for k there and there and there. The reason I got to do that is because if you remember back to the graphs of log functions, you know that the inputs of log functions can't be 0 or less. And so we need to be able to make sure that the stuff inside here and here is not negative and not 0. So Just kind of doing some mental math here. I've got 100 times 4 is 400, minus 2 times 10 is 20. So this is 380 on this side with this value 10. And then this one is just gonna be positive. So I've got, yeah, that's actually 382, isn't it? 380 also. So then I gotta check the -8 as well. I think this one's gonna work too, but let's just make sure. -8 squared is 64. 64 times 4 is 256, and then plus 16 is 272. So I need to make sure that this side is 272 as well. I've got 64 times 3, which is 192, plus 80, which is also 272. These both work. So both of these solutions are okay. Okay, this is a different kind of equation because this is an exponential equation, and I'm going to call it an exponential equation because there is an exponent in it where the variable is in the exponent. So this is different from a polynomial because in a polynomial, the x is the base of the exponent. To solve this equation, I'm going to add 7. So I get -29 on this side equals, and then negative e to the 2n minus 7. I think I better divide both sides by -1 to get rid of those negatives. So I get e to the 2n minus 7 equals 29. Now we need to rewrite with a log. So this is the process that's kind of new to us today. So I'm going to rewrite. It's log base e of 29 equals 2n minus 7. But we don't write log base e. We should write ln instead. So we're going to write ln of 29 equals 2n minus 7. Got a little dot there. Okay, there we go. So I guess I could figure out what ln of 29 is, but for now I'm just going to finish the problem off, and then we can put the whole thing in our calculator at the end. So I've got ln of 29 plus 7 equals 2n. Divide both sides by 2, and I get n equals natural log of 29 plus 7 all over 2. And that's a calculator problem. So I'm just going to type that in my calculator and get a decimal approximation. And I found that that was 5.184. So we'll circle this. You could also circle this other thing over here, this thing. But I'm happy with this decimal approximation for these kinds of problems. I'm going to zoom out so you can see the whole process. Then I'm going to move on. Okay, the next strategy that we need to apply from last week is combining these rules into one log. And the reason that we need to do that is because we can't actually make any progress on an equation like this one without doing something like that. So this, because there's a minus here, I can rewrite this as log base 5 of 2 over x, and that's equal to 1. So then once I have that rule taken care of, now I can rewrite. But this one is a log equation, so I'm going to rewrite it as an exponential equation to make progress here. So I have 5 to the 1 equals 2 over x. So then I need to figure out what the x is. So I'm going to, let's say, multiply both sides by x. So I get 5x, because 5 to the 1 is just 5. So I get 5x equals 2. So then I need to divide both sides by 5. So I get x equals 2 over 5. There's my answer. I probably should be checking all of these in here, but I promise you this one will work. Here's the next one. This one has a plus in between, and so that means I'm going to rewrite it as log base 3 of x plus 24 times x. And so there's these like big parentheses around this whole thing, and this is still equal to 4. So let's rewrite. I'm going to rewrite as 3 to the 4th equals, and then I'm going to write x plus 24 times x. Here I need to distribute and then see what I can do next. So I know 3 to the 4th is 81, by the way. So I'm going to write 81 equals x squared plus 24x. And look at that. I have created another quadratic equation that I need to solve with those same methods that I've been talking about. So let's see where that goes. I'm thinking, and I'm not sure if this is going to work, we'll just make sure. What I know is that I could try to find factors of 81, negative 81, that add to 24. And so the factors that add to positive 24 that multiply to negative 81 are x minus 3 and x plus 27. If you FOIL that out, you're going to find out that this thing right here is equivalent to this thing. We are really close to being done. This is just going to give me that x is equal to 3 and x is equal to negative 27. Again, I need to go back and check those because you remember when we talked about the domain of log functions and how there's going to be a little bit of an issue here because this negative 27 right here, if we put that in here at the beginning for x, you're going to see, okay, well now I'm taking the log of a negative number and that doesn't work. This is an extraneous solution, and so 3 is the only solution here. This is my last problem as an example for today. In this one, I have an exponential equation, and this one has some stuff I can do before I even take a log of both sides. So this is equal to e to the 6 plus x because of what we know about exponent rules, plus 9 equals 51. And so we're going to rewrite this like that because this exponent rule says that I can combine these two exponents by adding them. I'm going to subtract 9. I'm going to get e to the 6 plus x equals 42. I'm going to rewrite with a log. This time I'm going to jump to what I know I need to write when I have log base e, which is ln of 42 equals 6 plus x. The only thing I need to do now to get x by itself is to subtract 6. And so I'm going to rewrite x equals ln of 42 minus 6. That's a calculator problem again because nobody knows what the natural log of 42 is. And when I do that, I get that x is equal to negative 2.2623. So there's my answer. All right, two sort of big ideas with these kinds of equations. If you have an equation that has a log, so if you see something that says log base 2 of something equals something, and you need to solve for the stuff that's in here, or if you have something that's like ln of x equals 47, whatever, you need to rewrite it with an exponential equation. So you need to use that log properties rule, which I'm writing here, so that you can change forms. The thing is, sometimes you don't just have one log, so you have to do some work to get to one log. Same thing with exponential equations. Sometimes you have to get it down to be one exponent, and then you can rewrite it with a log. Either way, most of the time when you do these equations, you have to change what form the equation is in so that you can solve the equation. Okay, last, you have a practice sheet to complete. I will be asking you to turn it in at the beginning of class tomorrow. If you finish it in class today, that's great. Just turn it in then. But if you need a little bit of extra time, get it to me by the beginning of class tomorrow. I will see you then. Have a great day.